Hi everyone, another A-level video, this time focusing on the enhancement of woods. So these are all the things that you need to know for the specification. I must admit it's a very strange mixture of things. Some of them are really easy to understand, like pigments and preservatives, and others are a bit odd. Some of them I've never seen come up in the exam, but that doesn't mean that they can't catch you out. So we're going to go through each of these. If I think that it might be beneficial for you to watch a YouTube video on things like that, then I might signpost you to some videos. But apart from that, hopefully we cover everything you need to know. So this is some of the easier stuff to get your head round to begin with. So some things that you can do to woods, and these ones here, resins and laminations. This is more commonly seen in things like manufactured boards. So things like plywood and also chipboard is a very good example. So chipboard is not the most aesthetically pleasing wood. It's made up of loads of little chips. And it's made from compressing these chips with a resin. So urea formaldehyde is used, which is a thermosetting polymer or plastic. And the advantage of setting these wood chips with this resin is it gives the board a uniform strength and is very stable. So when we're talking about wood being stable, we mean that it's not going to twist, it's not going to warp, where natural materials can quite easily, especially if they're exposed to water or change in temperatures, or even if they're just drying out, they can twist and crack quite easily. But the big advantage of manufactured boards when they've used resins and laminations, which is just layers of wood on top of each other, it normally results in a uniform strength and a very stable material. So that's kind of covers that. Laminations, so this is where you might have, for example, a kitchen counter, and you might want to put a veneer onto the top of it. So what you can do is you can make a kitchen counter look more expensive by using a veneer, such as a natural wood, onto the top of there, and then that is coated in something called melamine formaldehyde. And this can give a very hard, kind of scratch-resistant surface. So you can laminate different materials on top of each other to give different properties. So sometimes it can be a natural wood like oak, mahogany, teak, something like that. And then by putting the thermosetting polymer, melamine formaldehyde, over the top, it's going to give it a really hard wearing, high gloss finish. So that's lamination. And sometimes these resins that are used in things like melamine formaldehyde and urea formaldehyde, sometimes they can be impregnated with a fire retardant chemical. So this is really good for indoor flooring if you think about it. If you've got a type of manufactured board that has a resin with a fire retardant in it, it's going to help to stop the spread of fire. It doesn't mean it won't catch fire, but it means it won't easily spread the fire. So you can have resins with these fire retardants that can hopefully slow down the spread of fire or sometimes stop it altogether. So there's some easy bits to begin with. The next thing we're going to look at is called pressure treatment. So this is a really important one, one that you need to get into your head because this has come up a few times and is just a good thing for you to know about. So this is called pressure treatment of wood. It's sometimes called tannalizing, which you may find that if you type in tannalizing into YouTube or into Google, it'll come up with pressure treated wood. So I'm going to talk you through this process. There is a YouTube video here that you can have a look at, but the easiest thing as well to do would be to just put it into YouTube, pressure treatment process. So this is basically where preservatives are pushed into the wood, and we're going to explain it step by step. So the first thing is a timber, so it might be something like pine. It's normally a softwood, something that's used outdoors for things like sheds. It could be larch, it could be cedar, it could be all different types of things. but the timber is loaded into a chamber and basically all the air is sucked out. Okay, so all of the air is sucked away from the chamber and from the timber itself. Then number 2, the whole chamber, the cylinder, is flooded with a preservative, and the preservative they usually use is called copper sulfate. And if any of you have ever been to B&Q and you've seen wood that looks a bit green, that has been pressure treated because it turns it a slight greeny kind of look. So outdoor wood sometimes can have a slight green tinge to it, and that means it's been pressure treated. Okay. Another good advantage of using copper is that it has excellent fungicidal properties, so it stops things like rot and fungus and things like that from invading into the material, as well as things like insect attack as well. So it's been filled up. Number 3, basically the pressure is increased, and under hydraulic pressure, basically the preservative is pushed right deep into the material. It's not just on the surface, it's actually penetrated quite deep into the material. Okay. Next, the excess preservative is extracted through another vacuum, and then it's left to dry. Okay, and the big advantage of this is that this, like I said before on step 3, the finish is not just on the outside of the wood. So even if it was chipped, or if you drilled into it, or if there was a scratch, the preservative would still protect the wood, where in contrast something like a paint or a varnish, the damage would cause the wood underneath to start rotting or be affected by insects or weather. Okay, so the pressure treatment process, the main reason it's used is it protects exterior wood from fungal and insect attack. Fungal attack caused usually by wet conditions. Right, the next couple I'm going to talk about are, well, this one actually links quite nicely with the pressure treatment process I've just chatted through, so I'll go over these first. So in that preservative, which we just said was a copper sulfate, you can actually add pigments into it to get a different colour that comes out. So this can sometimes make softwoods look more expensive, like hardwoods and things, and can enhance the aesthetic. So during the, actually the chemical that's put into the kind of cylinder where you pressure treat the wood, you can put these different colours to change the colour. You can also put fire retardant preservatives, kind of fire retardant just like you did with the resin, but you put it into the pressure treatment cylinder again, in with the copper sulfate, and that can help on things like roof joists and cladding, things that are on buildings where you don't want them to go up in a fire really quickly. So you can add in things like fire retardant preservatives. So those are things that you can add to the pressure treatment process. This one is a weird one. This is almost like ways of making a composite in a way. So this is called a structural composite lumber, or called structural composite lumber. It's used in architecture quite a lot, so it's quite interesting. It looks quite strange, but it is basically strands of wood that are layered with resins. So it kind of looks like a chunkier version of chipboard, but they are pressed and heated to cure them. And what happens is you get a very stable wood billet. So when we say billet, this isn't a board, this is a chunky bit of wood, you know, that could be used in a roof joist, or in building, or, you know, where you might use something like this, it's replaced with this. And why would you do that? Because of the stability. Again, it's all about making the material more stable. So for example, this natural piece of material here, you can see the natural grain that's on here. If this was to get wet and then dry, this could potentially crack along here. It could twist and warp, it could bend. But this, because it's got multiple layers in lots of different directions with resin holding it all steady, is going to be much more stable and more less susceptible to warping. So that's the advantage of this one, structural composite lumber. Next one is similar again. It's similar to the one I just spoke about, the structural composite lumber, but instead of using little random chips of wood, you actually use proper big layers of wood. So this is like plywood on steroids. It's like the beefiest plywood you would ever see. So you can see that it's lots of layers of veneer layered together, and it has big advantages in structural applications like beams and joists and rafters. And the advantage is, again, it's less prone to warping. It's better, it doesn't split as much, it doesn't shrink as much. Also, you can achieve pieces of material that are much bigger and wider because you might be limited with natural materials, and it has greater load-bearing properties. So in lots of different directions, it is going to be stronger, in contrast to maybe more traditional pieces of timber. So that's laminated veneer lumber. It's basically beefy plywood. And I'm not going to lie, this one is weird. It's in the specification. I've never seen it come up in the exam, but we'll chat through it really, really quick. I had to do quite a bit of research into this. We even went to speak to some of the science teachers about it. It's a modified natural polysaccharide. So those of you that do biology will know this is actually a type of cellulose, and it's the main substance found in plant walls, the cell walls, to help the plant to remain stiff and strong. Okay, so woods can be treated impregnated with a modified natural polysaccharide, and that would cure within the structure of the wood right down to the cell structure of the wood, and basically it produces wood that has a much increased hardness, toughness and stability. So all day long this is really useful for floorboards. Okay, so some of you might have floorboards like this at home. You want them to obviously be very, very hard. You want them to be nice and tough so they're not going to, under impact of footsteps. You don't want them to be breaking or fracturing. And you also don't want them to be twisting or warping, so you want them to be nice and stable. So by adding this modified natural polysaccharide, basically cellulose, to this wood, you are basically making it stiffer and stronger, which is quite often used in flooring. Hope that was useful. See you on the next video.